Greetings! This is Unit 6, Module 3, Session 5. The name of this home connection is Danny's Data. It's a two-pager. Please make sure your name and number is at the top. Give yourself credit for that hard work. I see a number plot down here, so let's see what's going to happen. Danny collected data about the length of 12 worms he found while he was digging in his yard. He used the data shown, or no, we're supposed to use the data shown on Danny's line plot to answer the questions. So it looks like we're talking about number of worms here. So we've got 1 worm, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 12 worms, and each of these worms was a different length. Well, I guess a couple of them were the same length. Ooh, even those 3 were all the same length. Okay, and we're talking inches here. So let's see what happens. It says, what is the range of the data? So the range is the difference between the length of the longest and the shortest worm. And don't forget, those we call maximum and minimum. So the longest worm was 5 and, ooh, that's not the right color. I wanted to highlight that. The longest worm was 5 and 7/8 inches. The shortest worm was 4 and 2/8 inches. So we would say that 5 and 7/8 is the maximum, 4 and 2/8 is the minimum. So what is that equation going to look like? And hopefully my pen is the right thickness. We're going to find out. 5, ooh, too thick. We're going to try that real quick. Sorry to make you wait. 5 and 7/8. And we're going to subtract, right, because difference means subtract, the shortest is the worm, 4 and 2/8, okay? Well, the first thing that I'm going to do is I'm going to subtract the 5 and the 4, okay? And if I do that, what do I get? I get a 1. Excellent. Now, what if I then go ahead and then subtract 7/8 minus 2/8? Remembering that we can't change the denominator because the denominator is just telling us how big the pieces are, right? We're talking about our whole numbers are cut into 8 pieces. This is how many of the pieces we have. We have 7/8 and I have 2/8. 7 of them minus 2 of them is 5 of them. So the range is 1 and 5/8 inches. What does that actually mean? That means the range is how much information is between the biggest and smallest number. Because if these are the only lengths that I know, I don't need to know what's over here, and I don't need to know what's over here. All of my data lies in between these two numbers, and that amount here is 1 and 5/8 inches. From here to here is 1 and 5/8 inches, okay? What is the median? And fortunately, they even give you the definition where they tell you that the median is the middle value in the set of x's. And I particularly like to do this methodically. And I'm going to just take a little yellow mark here and just to work my way inward. So I'm going to take the outsides, and then I'm going to go in 1x. I'm going to go in another x, in another x, in another x. And then look what I have left. I do have 2 x's. Sometimes you'll have 1, sometimes you'll have 2. Fortunately, these 2 are on the same number. My median is 5 and 2/8. Let's write that down. Don't forget to label. Then it says, what is the mode? And the mode is the most common worm length. So that is the value that has the most x's. Which one has the most x's? Well, hopefully your eyes are drawn to this one here. Now, a couple of them have 2, but this one has 3. So that is the mode because it has the most number of x's. That number occurs the most. So that is 5 and 3/8 inches. Let's write that down. Next it says, what fraction of the 12 worms were less than 5 inches long? Now let's start with just figuring out how many worms were less than 5. Notice it does not say 5 inches or less. It says how many of the worms, what fraction of the 12 worms were less than 5 inches. So let's find 5 inches. Okay, I'm going to identify this with maybe a blue circle. So this is 5. It says less than 5. Okay, so we cannot include this x here because it says less than 5. This x says that this worm was 5. It says what fraction of the worms were less than 5. And if I use that same color, I see this one, this one, this one, and this one. There are 4 of them. Okay, so let's think about this. What fraction of the 12 worms? Well, I know that I have 4 of the 12. That as a fraction would be 4/12. 4 out of 12, okay? Because that's how you can read a fraction, 4 out of 12, okay? What fraction of the worms were longer than 4 7/8 inches, but shorter than 5 5/8 inches? Now, once again, it doesn't say 4 7/8 inches or longer. It just says longer than 4 7/8, shorter than 5 5/8. And for this, I'm going to choose yet another color. Let's see if I can find something that's a little pretty different. So something maybe orangey. Let's see if this works. Sorry, it's taking me a hot minute here. That one's not too bad. Looking at a color wheel here. So I go up here, and so I'm looking at 4 7/8, 5 5/8. Okay. 4 7/8 is here. Oh, that kind of looks yellow. Sorry about that. Let's just do blue. How about that? 4 7/8, 5 5/8. I'm going to double check my numbers because my phone made a noise and I don't remember what I was reading. Yeah, it says 4 7/8, 5 5/8. Okay. Longer than this number, shorter than this number. So that means I need everything that is in between these two, right? I cannot count these two. Okay, I was hoping that this would actually, I didn't mean to draw on it, but you can't count these two, and there's nothing here to count. So I'm going to count all the x's in between 1, 2, 3, 4, 5, 6, 7. So once again, it says to do it as a fraction. We know that that would be 7 of the 12. I got to pay more attention. I'm a little tired. And as a fraction, that would be 7 out of 12, 7/12. Okay? If you want to, at any point in this video, do some of these on your own, please, 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 please do that. Okay? What fraction of the worms were more than 5 inches long? Let's do that one next. More than 5. So I go up to my, and we're gonna just do this by sight. Okay? I want to see how well we can do that. More than 5. Where's more? Well, anything to the right. So don't count this one because that is 5. We want everything that's more than 5. 1, 2, 3, 4, 5, 6, 7. Again, interesting. 7 out of 12, 7/12. If Danny laid the 2 shortest worms from end to end, how long would they be together? Show your work. I'm going to set up this problem with you, but I would love for you to finish it on your own. My 2 shortest worms, 4 2/8, 4 5/8. Let's write those down. 4 2/8. Oh my goodness, I already forgot what that other number was. 4 2/8 and 4 5/8. Woo! So what am I doing here? Combining. If you laid them end to end, how long would they be together? Make sure that you answer it in units. Okay. Next, it says if Danny put the longest and the shortest worm end to end, how long would they be? And I'm just going to review that you know those numbers, but I'm going to let you write that equation and solve it on your own. Shortest numbers here, longest numbers over here. That means my shortest number is 4 2/8. We already know that. But my longest worm is 5 7/8. You're going to add those 2 numbers together. Here on page 2, hopefully you paused the video and you did that last question. That'd be awesome. But here on the second page, we're going to add and subtract some mixed numbers, okay? As I look at these, once again, I can combine my whole numbers first and then combine my fractions. If the denominators match, like 3 and 3, thirds and thirds, eighths and eighths, sevenths and sevenths, if the denominators match, then we can simply add the numerators, correct? So if I combine the 2 and the 4, I get a 6, and then it's going to be something thirds, right? Well, 1 plus 2 is 3, and I can simplify this further because I know that if I have something cut in thirds and I have all 3 pieces, what do I have? Well, that's 1, isn't it? So instead of writing 3/3, let's write 1. So that means we have 6 and 1. So what would that be? Well, that number's actually 7, okay? If I move to the next one, and I'm only going to do this next one with you. Actually, I'm going to skip and do this one because I think this one's just a little bit more complicated. If I have any problem, there's a couple ways you can do this, and man, I would really have you consider doing it this way. If I'm subtracting, and the first number, the larger number, 8 4/7, it's the larger number, has fewer numbers in the numerator than the number that is going to be subtracting, we're going to have to borrow from one of the whole numbers, aren't we? Because 4/7 minus 5/7 isn't possible unless I take from the bigger number. So what if we did this? And I might even zoom in just to make this point a little bit easier. And I'm going to shrink my pen here a little bit. If I multiply these two numbers and then add this and keep the denominator the same, I'll have the improper fraction. And the same for this. If I multiply these two numbers and then add the 5 and then keep the denominator the same, I'll have my improper fraction. Let's do this. 7, oops, that's not what I wanted. 7 times 8 is 56. 56 plus 4 is 60, right? So I could say that this number is 60/7. And you're like, well, that's true, but why is that helpful? You're going to see here in a second. On the other side, if I take 7 times 3, that's 21. 21 plus 5 is 26. Keep the denominator the same, I have 26/7. Okay, so I found the improper fraction for each of the mixed numbers. Okay, now I can subtract just like it wants us to, and it's going to be a little bit easier this time for now because I can subtract 60 minus 26 because this number is bigger and we could stack it and subtract it. If you want to do it in your head, you can, but I'm a fan of just writing it down. So if I do 60 minus 26, I can't subtract from the 0, so I'm going to borrow, turn that into a 5. This becomes 10. 10 minus 6 is 4. 5 minus 2 is 3, so I have 34. So my answer over here would be 34/7. Okay? Then if I want to put it back into a mixed number like I had here, which is good, it's good to know, I always think to myself, well, I know that I'm going to have a whole number, just like this, and then I'm going to have some fraction over 7 because I'm working with 7s. I can't change the bottom number, okay? So I'm going to have a whole number, just like this 3, and then I'm going to have something over 7, just like this 5/7, okay? So let's do this. How many 7s fit in 34? Well, I could do 4, and that would give me 28, right? Because 7 times 4 is 28, and I'm just going to make a little note of that, okay? 28, okay? Oops, that's not an 8. That doesn't look like an 8 either. Let's just start that number over. There we go. If 7 times 4 is 28, how many is left over to make 34? Well, the answer is 6. So 4 6/7 is my mixed number if I'm going to change this improper fraction into its mixed number form. If you want to double check your work, remember how we did this kind of triangle pattern, multiply and add? Well, double check your work here. 7 times 4 is 28. 28 plus 6, 34. So I know that I did that correctly. And it's great to check your work, okay? If you wanted to do it the other way, and I know that this video is taking a little time, but some of you, your teachers may have asked you to do it a different way. That is not incorrect. But if we wanted to, I could subtract the whole numbers first. What is 8 minus 3? And I'm going to do this in a different color so you can see that I'm doing it a different way. Well, I'd have a 5. And then I have to worry about 4/7 minus 5/7, right? I cannot subtract those two numbers because this number is not big enough. So you know what I'm going to do? I'm going to take 1 out of this number, okay? And then I'm going to change so that becomes a 4, and then I'm going to add 7/7 to this number. So I took 1 out, okay? If I take 1 away, what is 1? Well, 1 is 7/7. And if I add them together, then I have 7, 8, 9, 10, 11. I have 11/7, okay? Now I can subtract the 5/7. If I do that, I would have 4, and then help me out, 11 minus 5, 6/7. It's the same answer. Done a little bit differently. It's borrowing, and we know borrowing, but sometimes it can feel a little different if you're borrowing 1 because you're going to use the fraction version of 1. 7/7 is the same as 1. Completely an option. And you might not like this step here, which is why you might do this. You might choose to do this method. That is up to you. And if I would always say, go with your teacher's method or the method you're most comfortable with, because if you're successful, life is good. Nobody's going to complain if you get the right answer. Danny found one more worm, and he wanted to add the data to his line plot. He wondered how it would affect the original mode, median, and range. What is a length of the worm could be that would not change the mode? Okay, and you're going to have to flip back to that page, and I can't really do that for you right now without messing up the video. But you have your paper. Look at the line plot. You don't want to change the mode. So you can put an X anywhere except 5 2/8 and 4 7/8, correct? Because if you put an X on either of those numbers, you would now have 3 X's on those, okay? So I'm going to say anywhere except, let's see, 4 7/8 and 5 2/8. Okay, does that make sense? Because if you're looking at your line plot, 5 3/8 has 3 X's. And that's the mode because it has the most. If you don't want to change that, you can't put X's on these two numbers or else they will now have 3 X's, and then you don't have the same mode. What is a length that would change the mode? Well, we actually just answered that right here. What is a length of the worm? What is a length the worm could be that would not change the range? And we know that the range is the maximum minus the minimum, so the only thing that we have to do is choose any number that is not higher than range. Higher than max/min. Okay, so you can choose any number in between the highest number and the lowest number. So what is a length that would change the range? Any number. This should say or lower. So higher than max, lower than minimum. Number higher than max / lower than the minimum. Sorry that my pen's not gripping as well as it normally does. So I'm not getting a really good handwriting on there. Wow, even having trouble with my T's. What is a length the worm could be that would not change the median, the middle number? And this is going to be an issue because the only thing that we can do is put an X on 5 2/8. Because the median is 5 2/8 and there are 2 X's on it. If I add another one to 5 2/8, the middle value would still be 5 2/8, What is a length that would change the median? Anything else. It would shift it either to the right or to the left, okay? And I know this has been a long video, but there are so many good vocab terms in here we need to know. And if you have questions, as usual, make sure you ask someone, okay? We love to help. Anything we can do to clarify your understanding, we are willing to do. Later.